This is a really interesting problem for the GMAT Focus Edition, or what's the new GMAT now in 2024, which should be the GMAT going forward, because the people who make the GMAT have been quite vocal that they're getting rid of geometry, yet there still are some geometry-related or geometry-ish questions on the exam. They're certainly rare, but they do come up, and I think it pays to know the basics of geometry. And I think this question is a good example of the type of geometry question that I've seen on the new version of the exam. It's also a great illustration of a concept that I call go big or go home, which we'll have some fun with in a second. The first thing you want to do when you see any type of figure-related question is make sure you draw a reasonable approximation of the figure on your scrap paper. This will give your mind a chance to process the data of the problem in a productive way. This is particularly helpful, I've found, if you suffer from a lot of anxiety during the exam. It might not be like the perfect cure for that, but it helps. And because they're asking me about this sort of heavyweight line, I'm going to emphasize that in my diagram. And note that my diagram's not perfect, and it doesn't need to be perfect. It just needs to be reasonable. If you're not familiar with the concept of perimeter, or if it's been a while, then a perimeter is the sum of the side lengths of a shape. And you can see that this problem uses that language right here when they tell you each of the squares has a side of length 1. Now, just in case it's also been a minute since you thought about what a square is, that means 4 equal sides joined at 4 90-degree angles. It means it's perfectly perpendicular. It forms a perfect L shape at each angle. Now, if you've already attempted the problem, you might have noticed that something kind of annoying happens when you try to find the sum of all these side lengths, which is that this one is clearly 1, this one right here is clearly 1, this one right here is clearly 1, and then you've got a bunch of others that you probably were able to figure out are going to be 1, but then you've got these pesky other sides that in some ways are clearly not adding up to 1, and that can be a little bit annoying. Now, a little bit of good news is that if we sum all of these, we can still get rid of at least one of the answers, because you probably, when you did the problem originally, noticed that there's 10 of those sides of 1. So the answer is definitely not 8. But it's also clearly bigger than 10 because we haven't even counted these lengths up. And what can be frustrating there is there's no good way to calculate the sides in red that I've labeled red here directly, meaning there's no formula. Some of you might struggle with visual estimation. And so this is where the go big or go home strategy can really help out. So again, if you can't find a way to calculate a length or an area, which is a way of measuring 2-dimensional space, or a volume, which is a way of measuring 3-dimensional space, if you can't calculate those directly using formulas or can't use deduction to figure them out, then what you want to do is you want to make a larger shape that you do know the length, area, or volume of, and then subtract away the known negative space. Let me illustrate what I'm talking about. So what I'm going to do is I'm going to go big. I'm going to make this larger length right here, because I know for sure, because the side length of this one square is 1 and the side length of this other square is 1, that this will for sure have a length of 2. So that's a larger known shape. I'm going big. And then what I'm going to do is I'm going to subtract away the known negative space, meaning the space that's not involved in the shape that I want to measure. I want to measure this and this, but not this. But this is known right here. This I know is 1. So if I know the whole big thing is 2, and this one segment of it is 1, then these remaining pieces that I've drawn in red here have to add up to the other 1. That will yield a total length of 2. So that's the go big strategy. We can use that same concept on the other side of the shape. We know that this is 1 right here, this is 1 right here, so the total is going to be 2 again. And then we know that this negative space that we don't want to count in this piece is also 1, so therefore this piece and this piece must add up to the other one to make a total of 2 for this whole length from top to bottom in the shape. And that's how you could calculate your exact answer, which is 12. Again, on the new exam with significantly reduced geometry, is that something you're going to get a ton of mileage out of? Probably not. But when it's useful, is it very useful? Yes, I've found it to be, because if you look around the web, you'll find some alternate solutions to this question that redraw the figure. And if that resonates with you, awesome, use that for sure. But I've found redrawing figure questions doesn't always scale to a wide variety of questions. Yeah, it'll work on one question here and there, but this go big or go home strategy is something that'll apply anytime you can't calculate a length or a volume or an area directly. So I found that it scales a little bit better than some of the redrawing techniques. So if you didn't like those redrawing techniques, or you're not a fan of hardcore visual estimation and just ballparking things, This is a great way to calculate the answer exactly. So that's the go big piece. What about the go home piece? Well, if you go big and you can't find negative space to subtract away, or you're not sure how to calculate the problem, even though you found this larger known shape, then it's highly likely that you don't have a good solution to that question, and you should immediately guess and move on to the next problem. As weird as this might sound, the GMAT is not strictly a test of accuracy, and so it's totally possible to get super elite scores, even though you might give away or end up skipping some questions that you're not 100% sure on. Because of the way the time pressure of the exam works, this is really important for a wide variety of students. And if you want to understand how the scoring algorithm works, how it's different from other exams, then I'd recommend you head to our website, thegmatstrategy.com, and check out our free video that we have breaking down how the algorithm works and how you can strategize better once you know how it works. We'll also put a link to that video below or somewhere around this content. And if you have questions about what I'm recommending or what I've presented here, feel free to comment below or DM us at the GMAT Strategy on current social channels.